All right, we are recording. Welcome everyone to the January program meeting for the Licking County Computer Society. We're glad to have you. I'll be your presenter this month as we look at virtual computing. What is it? What are some of the use cases? And then a demo in case you ever wanted to try it out for yourself, just a little introduction. If you have any questions, feel free to speak up. And if you have any corrections, let me know too, because I don't know everything, obviously. All right, I'm going to go ahead and start sharing, Everett. Okay. Someone online, let us know when you can see my presentation.
I can see it. I can see it.
All right. So again, my name is Adam Drake. I use a little help from Chat GPT again on this presentation like I have on many of the previous ones. And this month we'll be talking about virtual computing. So the first thing you might be wondering is, what is virtual computing? Well, virtual computing refers to the use of software-based technologies to create simulated or virtualized versions of computing resources, such as servers, storage, networks, entire computer systems, and I'll throw in there desktop computers also. The approach enables multiple operating systems, applications, or instances to run on a single physical machine or infrastructure, sharing and efficiently utilizing resources without any physical constraints. I shouldn't say without any physical constraints, I will say without the traditional physical constraints. Virtual computing evolved from the mainframe time sharing setup of the past, which is still in use many places today, to the hypervisor-enabled virtual machines in the 1960s. Server virtualization transformed IT infrastructure in the late 20th century, paving the way for widespread cloud adoption this century. Today, virtual computing integrates with technologies like containers and AI, shaping modern IT architectures. Virtual computing is essential for efficient resource use, scalability, and cost reduction in modern IT. It enables running multiple applications on a single machine, optimizing hardware efficiencies, providing flexibility, enhancing security, and supporting agile development, while also ensuring a cost-effective and resilient computing environment. And the reason why it's so cost-effective and efficient is because, in a nutshell, instead of having one physical server for every service or server you want to have running, you can have them share physical hardware and be a virtual server. So you can, basically have more virtual servers on a single device and have to have less individual physical servers. That's where the idea basically starts. All right, let me know when you can see my next screen, please.
Now?
All right, sorry about the delay on that. So looking at some types of server virtualization technologies. Server virtualization, also referred to as hypervisors these days, are software or firmware that enable the creation and management of virtual machines on physical hardware. There's two different types. A type 1 hypervisor runs directly on the hardware. It manages the VMs without needing a host operating system. Examples of this include ESXi by VMware and Hyper-V server by Microsoft. The Type 2 hypervisor is a hosted alternative. It operates on top of a host OS, suitable for developing and testing. Examples include VMware Workstation and Oracle VirtualBox. And the type I'll be sharing with you guys at the end of the presentation is a Type 2 hypervisor that runs on top of Windows, and it's actually Oracle VirtualBox. Another type of virtualization technology is desktop virtualization. So a VDI, or virtual desktop infrastructure, is a technology that runs desktop operating systems as virtual machines on a centralized server. End users access their desktops remotely using thin clients or other devices, allowing for centralized management, improved security, and flexibility in accessing desktop environments. And I do have another example, if we have time, of something that's sort of like a VDI running on my server at home, assuming all the stars align and I'm able to connect to it from here. Another part of desktop virtualization is remote desktop services. That's a Microsoft technology that enables users to access a desktop or specific application hosted on a remote server. It's definitely the most commonly used technology for accessing VDIs. It allows for remote connections, facilitating centralized management and secure access to computing resources. And then the third type, and the type we'll be speaking about at least today, is network virtualization. So software-defined networking separates networking control and data planes, allowing centralized management for dynamic resource optimization. This enhances flexibility, scalability, and automation in network configuration, simplifying administration and adapting to changing business needs. A VLAN, or virtual local area network, is a technology that divides a physical network into separate, isolated logical networks that can even be across different geographical locations. It improves network efficiency and security by allowing devices to be grouped based on common criteria, even if they share the same physical limits. So an example of this would be if you go somewhere and you want to connect to the Wi-Fi and you see two Wi-Fi points. One is locked out and it's for the business that you're visiting. Then another one will say the same business name with guest and there's no lock pad and you can get right into it. That'd be an example of a separate virtual network that's on the same hardware. But it could be more restrictive. It could have quotas in place to prevent, guests from using up all the bandwidth. So
Could you repeat that last part?
yeah. So if you go to McDonald's and they have two Wi-Fi networks, one says McDonald's employees only with a lock pad on it, and one says McDonald's guests without a lock pad, and that's the one you're able to connect to and use. That's an example of a VLAN where you have virtual networks separate from each other, separate access, but they're on the same physical hardware, utilizing the same networking equipment, Wi-Fi antennas, and so forth. But having them separated allows for preventing access to secure network components and servers and so forth that are internal to McDonald's. And also it can be used as a way to limit the amount of internet bandwidth that's being taken up by the guest.
Thank you.
That's just one example of VLAN. We won't be talking about network virtualization as much, but I just wanted to make sure everyone's aware of it. All right. Let me know when you can see the next slide, please. That takes a second. There we go.
Got it.
All right. So looking at some of the use cases of virtual computing, data centers and server farms, they utilize virtual computing for resource optimization and server consolidation, as I kind of mentioned previously. It's also helpful with disaster recovery and high availability. Development and testing environments use virtual computing to accelerate software development lifecycle and allow for efficient testing and debugging, because you can do that in a virtual environment without worrying about, messing up your physical laptop per se. If you have a virtual environment where you can test, you can either reset it to the pre-testing condition or just wipe it away and start from scratch without having to, completely rewipe your development environment. Another option is end user computing. People sometimes use virtual desktops for remote work. I know people that use VDIs with their own computer to log into the VDI at work, and they do that instead of having a dedicated physical machine at their work. And that's related to bring your own device, BYOD they call it, where you can bring your own device. Your device doesn't have to have all the security in place that your company laptop would have, but you can still use that device to have a virtual connection to a virtual desktop in the company's data center. Other use cases for network infrastructure virtualization are SDN, as I mentioned on the previous slide, which is the software defined networking, and then the network function virtualization. I'm going to attempt to change slides here. Okay, there it is. All right, so what are some of the popular virtual desktop solutions? One, I mean, chances are you may have heard of one of these at least. VMware Workstation is a popular desktop virtualization product that allows users to run multiple operating systems on a single physical machine. It's widely used for development, testing, and virtual machine management. Oracle VirtualBox is the one we'll be looking at today. It's an open source virtualization platform that supports creation and management of virtual machines on desktop systems. It's known for its flexibility and compatibility with various operating systems. I know it runs on Windows Analytics. Not sure about Mac, and it probably runs on ESD too. Next one's Microsoft Hyper-V. It's integrated into Windows operating systems. Hyper-V provides a hypervisor for creating and managing virtual machines, commonly used in Windows environments for testing and development. Another one is Parallels Desktop. This one is specific to Mac OS. Parallels enables users to run Windows and other operating systems alongside their Mac OS. It's popular among Mac users who need compatibility and the ability to run Windows applications. Another one is Citrix Virtual Apps and Desktops. This is one I'm not as familiar with, but it used to be known as Zen Desktop and Zen App. Actually, I am familiar with Zen App, so I take that back. It's a solution from Citrix that allows organizations to deliver virtualized applications and desktops to end users. So with Citrix, what it does is instead of virtualizing the entire VDI that's running on the server, it'll virtualize a single application. So you'll launch your application, it'll run through Citrix. You think that it's running on your local machine, but really it's running on a server, and the UI and all the visual updates and feedback and everything are passed back through Citrix. Look like a local application. The next one on the list here is QEMU. Is how people say it, I think. It's an open source emulator and virtualizer. It supports various platforms, including Linux and Windows. It's known for its versatility and ability to emulate a wide range of hardware. I would say QEMU, along with KVM on the list here, this combination is the most popular combo for virtualization on Linux. Another one here is Virtual PC. It was developed by Microsoft. I don't think it's in use anymore, but it was a legacy desktop virtualization product that provided users with the ability to run multiple operating systems on a single Windows computer. It was definitely geared towards the desktop, and it's basically been displaced by Microsoft Hyper-V at this point. Last one on the list, but definitely not the least, is KVM, which stands for Kernel-Based Virtual Machine. It's a Linux kernel module that turns the host operating system into a hypervisor, and it allows users to run multiple virtual machines. It's often used in combination with QEMU, as I mentioned previously. Right, I'm going to do the next slide here. You should see a cloud. All right, that is not a mushroom cloud. Okay. So what is this cloud computing and virtualization stuff? Integration of virtualization and cloud infrastructure involves seamlessly incorporating virtualization technologies into cloud computing. Virtualization serves as a foundation, allowing the creation and management of virtual instances within a cloud. It optimizes resource utilization, enhances scalability, and provides flexibility for deploying and managing workflows efficiently. So the way I like to think of cloud computing is that they call it cloud computing for a reason, because the resources are up above the application layer, you're using them. To you, it's like a thick fog of data and processing. You don't really care how many servers there are, what technologies they're on, how they're load balanced. If one fails and the other one picks it up, you don't know it. It's all just a foggy cloud above you, and you're just enjoying the benefits of it, except when it starts raining. All right, maybe the last part of it. All right, next one here is infrastructure as a service. It's a cloud computing model that offers virtualized computing resources over the internet. Users can access and manage fundamental infrastructure components such as virtual machines and storage without the need for physical hardware. It provides scalability, flexibility, and cost efficiency. So an example of infrastructure as a service, you guys have probably heard of Amazon Web Services. So Amazon Web Services provides customers, usually business customers, the ability to essentially rent server time, database time, container management technologies. Allows people to have a server in the cloud, but they do everything with the server. They have access to the server operating system. Another one here is a platform as a service. It's a cloud computing model that simplifies application development, provides tools and services for building, deploying, and managing applications without dealing with the underlying infrastructure complexities. So this is somewhere between you don't have access to the core server in this case. You would like say the server is still running in the Amazon Web Services, but you don't log into the server like you do with the infrastructure of the service. You use the software that's running on the service to maintain your own ecosystem. D on here is software as a service. That's the lowest level, basically. Software as a service is a cloud computing model where users access software applications over the internet or on a subscription basis, eliminating the need for local installations and maintenance. So software as a service you might have heard of is something like Netflix. It's software that's running in the cloud. You're using that software from your machine. You're not logging into the servers that run Netflix and running the Netflix app on the servers, but you're utilizing the software as it runs in the cloud. The last one here is hybrid and multi-cloud deployments. So hybrid cloud combines on-premises and cloud resources, offering flexibility. Example of this might be a business that has, proprietary data they don't trust to be in the cloud, so they run it on their own servers, but they might utilize cloud servers to host data that's less sensitive or even test data that they don't mind being exposed, if there was a data breach. So that's a case where you might have hybrid. Another case would be if you had all your own local servers and you just use the cloud for backups. That'd be another example of hybrid. So multi-cloud uses services from multiple providers for improved redundancy and cost efficiency, avoiding reliance on a single vendor. That would be, and I don't think a lot of places do this, but if you had your infrastructure on AWS, but then Microsoft Azure, you wanted to have them as a backup, and you had replication across the two, and you could switch from one to the other at any time. Don't hear about that very often, but probably would be a good idea. All right. See the slide on containerization next. There it is. So I think containerization is the next step in the virtualization evolution story. A container is a standard unit of software that packages up code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. So a Docker container image, which is a type of container, is a lightweight standalone executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, settings, etc. So you can think of a container as like a virtual server, but way smaller. It shares the kernel with the Linux operating system host, and it only contains what the container software actually needs to function on its own. And so containers are much lighter weight than virtual servers. You could fit a lot more containers on a host server than you could virtual servers. The full operating system included virtual servers. Talking about challenges and solutions next. So a challenging computing is performance. Challenge could be resource contention and overhead. The solution would be to optimize allocation, use performance tools, consider hardware upgrades. Another challenge for virtual computing would be compatibility. A specific example of that would be legacy application compatibility. So the solution would be thorough testing, exploring virtualization aware applications, consider containerization for applications. Another challenge in virtual computing is the complex administration and monitoring that's sometimes involved. Solution would be to use robust management tools. Misread my note there. Automate tasks through robotic automation, which are not physical robots, but software robots. And adopt centralized monitoring. Another challenge is security. Vulnerabilities and hypervisors are bound to turn up. They're software after all. Solution would be regular updates, security best practices, network segmentation, as we mentioned previously. Things you want to do whether you have virtualization or not. Optimizing virtual technologies. You want to regularly assess and adjust resource allocation and use performance tools to measure. Efficiency. You want to deploy comprehensive management, automated tasks, and efficient resource provisioning. By the way, this list is not things you're usually going to worry about if you're on a virtual machine on your desktop. This would be if you're, using it for, the enterprise level mostly. And then enhance security. Regularly update your hypervisors, implement network segmentation, and follow security best practices. So if you had a desktop with a hypervisor on it, and you just wanted to run all your virtual machines on top of that, you obviously have to do the security updates on your virtual machines, but you don't want to neglect the hypervisor because it's the host of everything. Let me know when you guys can see the future trends in virtual computing. All right, you should be able to see it now. Some future trends out there are edge computing integration, which is extending virtual computing to the edge for real-time processing. Serverless architectures, which is a shift towards event-driven, on-demand serverless models. So containers are an example of a serverless architecture. AI and machine learning includes increased integration for enhanced automation. Container orchestration, which is the growing reliance on platforms like Kubernetes. Most Docker container environments are going to run Kubernetes. Kubernetes is used to manage the deployment of the containers and to scale up and scale down the number of containers based on demand. Quantum computing is going to have an impact on the exploration of virtualization and basically the performance characteristics and capabilities are going to expand exponentially if quantum computing ever gets mainstream. Security advancements will continue to address evolving cyber threats. Hybrid and multi-cloud evolution is going to keep keeping on, but things are moving to the cloud. They're going to work to make that more seamless. 5G network integration. It's going to improve connectivity between these serverless containers all around the world someday. And ephemeral computing models. There'll be a rise of temporary disposable instances of specific tasks. That's where you have a virtual machine or container spin up when it's needed and then shut itself down so that you're not wasting resources with downtime, essentially. So that brings us to Q&A and the demo. There's a nice picture. I'm going to change my sharing to my entire desktop screen here. And I'm going to start with the demo, but I want to answer questions at the same time because there's going to be parts of the demo while we're waiting for things to install and so forth. So let me try to share my entire screen here. It should look like the meeting. There it is. All right. All right, so looks like there might be a delay here. Are you guys still seeing the white internet browser screen, or are you seeing my desktop?
Neither.
Neither? How about
It's a
now?
folded ribbon, I think is what I'm seeing.
The blue thing?
Yes.
All right, my Windows desktop. All right, I'll try to, I can keep my eyes on the screen here. I can see there's a lag, so I'll try to pause as needed. But anyway, if anyone has any questions about what I talked about or what I'm doing here, feel free
I
to.
do.
Yeah, go ahead.
Boy, makes me feel funny because I got a strange idea that everybody except me knows. Nevertheless, are you speaking only to desktop, laptop? What are you telling anything to people that live on their smartphones?
Yeah, so smartphones are definitely applicable here too. You're using a lot more software as a service tools on your smartphone. A lot of what runs on your smartphone is really the processing power is relying on the cloud. So when you ask Siri a question, it's using servers in the cloud and AI in the cloud for Siri to detect what you're asking and try to answer. It's not only relying on the processing power of your individual phone in your pocket.
Excellent. That's what I anticipated you were going to say. Maybe I'm not that far out of the loop.
No, not at all. And the advantage of that is that you don't have to walk around with a super big supercomputer in your pocket, even though we basically do at this point. You can have a much lower powered machine in your pocket, and then the super machine is in the cloud because you're not using it all the time. So when you do need it, you connect to the cloud and come back. All right, so you guys can see my download folder here. Again, keep speaking up if you have questions. We're going to be installing VirtualBox. VirtualBox is the Type 2 hypervisor that we're going to use to host a guest operating system. I'm just waiting. Okay, you guys should be able to see the installation wizard now. I'm just going to go through here and select the defaults. Installing VirtualBox is very easy. Wait till the screen sharing catches up on the display here. All right, so the installation is complete. I'm going to leave the box check to start VirtualBox immediately. Looks like it started. All right. Make the window just a little bit bigger here. Touchpad. All right, so first thing we want to do is create a new virtual machine, right? So I'm going to hit on the plus button to add a new virtual machine. And it wants to know, oh, you know what, I did that wrong. The plus button would be to add an existing virtual machine. We want to create a new virtual machine, so I'm going to go with the heavily multi-pointed star shape. Could be a blowfish, I don't know. So once that comes up, first thing we want to do, so we can decide what the name of this thing, is pick an ISO image. An ISO image is something you download that allows you to install an
Excuse me,
Yes.
can you enlarge that font a little bit?
I can try. Yep.
Okay.
Display settings. I'll try 175. Is that better? That should be better.
Yes, yes, yes.
So an ISO file is going to be, we used to install operating system using CD-ROMs and DVDs, and we still use USB drives today to install operating systems. If you want to install an operating system in a virtual machine, use an ISO file. These are the same files that you use to create your CDs and DVDs and flash drives, except instead of creating them, you leave it as a file on your Windows desktop, and then you use that installer to create a virtual machine. So as you can see here, I have some ISOs for several different Linux and Windows versions. Which one do you want me to do? Well, we got Linux Mint, Arch, Debian. Arch, are you sure?
Yeah.
All right. That's a hard one. All right, so we're going to be creating a new Arch virtual machine. We'll call it Arch BTW. When you run Arch, you have to say, I run Arch, by the way. People like hearing that. So we're going to save it in the virtual machines folder under my users directory. And it recognizes that it's a Linux operating system. It even has an Arch logo over here based on the ISO file and the name that we typed in. It knows that we're installing Arch Linux 64-bit. We'll hit next. This is where you assign memory. So if you have, say, 64 gigs of memory on your laptop, you don't want to give it all of it. We'll try 32. That'd be definitely enough for a virtual machine. Which 32 number is it, guys? Do you know? I think it's that one, 32768. Virtual, if you want to, you can look at my laptop screen right here. It's probably easier. And then processor. If you have 16 processors, it doesn't hurt to give all your processors to a virtual machine. Unlike the memory, it's a little safer, but we'll give 8. And then it wants to create a virtual hard disk, which is the file where it basically creates a fake hard drive inside of a file that represents the entire virtual computer that you're creating. This one, we're going to make it 100 gigs should be plenty for this. Right about there.
How can you put more than what you allocated on your hard drive? You allocated 32 gigabytes on your.
That was memory.
Oh,
This is the file storage.
okay.
But that's a question. That's a good question because you can't. There is such a thing as over allocation, where you can have virtual clients that all think they have a 100 gigabyte hard drive when really they're all sharing a 200 gigabyte hard drive, and you get into a problem if you start going over the maximum on the host. But when people do that, it's because they're planning to add additional resources to the host in the future, so that the over allocation is not a problem. It's kind of like future planning, basically. So here's our summary of everything we're creating. We'll hit finish. And we will start it up. And it should bring up a window. Right now it tells us it's powering up the virtual machine. And here's a window showing the boot screen for the Arch installer. So we're going to go ahead and click Arch Linux install medium. It's doing some hardware probing here. Yep, welcome to Arch Linux. It's booting up the operating system in the virtual machine. It's booting the live ISO image in the virtual machine. All right, so the easy way to install Arch these days is to enter a command called Arch install. Wait for you guys to catch up. All right, you see I typed it in. I'll hit enter here. Checking versions. Any other questions about virtual computing while we wait for this to load?
Well, there's a hardware thing on your motherboard that has to do with virtualization.
Mhm.
Does your motherboard have to support that?
Yeah, so I'm not sure about this application on Windows, but on Linux, in order to use KVM, you have to have a processor that supports virtualization, and you have to have it enabled in your BIOS. Not sure about Oracle VirtualBox. Actually, I do remember having to enable it in Linux for Oracle VirtualBox. I already had it enabled on this machine when I installed Windows, so I'm not sure if it's required, but it probably is. But most modern processors do support virtualization, even this laptop. So we're going to go with English. We're going to go with the US mirror here. America's on here somewhere, North America, maybe. United States, there it is. And locale should be English, but we'll make sure. Yep, English US. Disk configuration, we're going to use best effort default partition layout using the 100 gigabyte virtual hard disk. And we'll stick with ext4 for the file system. We don't need a separate home partition right now. We don't need to encrypt the disk for this example. For the bootloader, I guess we're going to stick with Grub. I know when I'm installing on plain hardware, I get the system D bootloader option, which I prefer, but Grub's pretty good. Swap space is virtual RAM that lives on your hard drive. We'll go ahead and keep it on there for now. Host name, I'll leave it at Arch Linux. We're not going to enter a root password because our user is going to have sudo access. So we'll create a user. Username will be fine. Let me see if it'll let us do a blank password or not. Looks like it did. Confirm exit. I don't think that worked actually. So I'll put in a super powerful password here twice. And it wants to know if Drake should be a super user. Say yes. All right. Exit. Profile. This is where we're going to say we want this to be a desktop environment using GNOME. The graphics driver, we're going to stick with all open source. And GDM for the login screen is good. We're not going to have any audio on here. Don't need any additional packages. Network configuration, we want to use Network Manager, which is required when you use a graphical network management tool. Time zone, we'll stick to Eastern here. There it is. And then we're not going to mess with any optional repositories at the moment. Actually, I take that back. We'll add multi-line. It's always nice to add. So we will now hit install.
What was the repository you added?
Multi-live comes in handy when you want to use the Arch user repository, the AUR. So it's going through the script right now. It's creating the local file system and so forth. So I think while this is running, I'm going to see if I can get to my server so we don't have to sit there and watch that install the whole time. So let's see here. I go to my VPN software. All right, I'm already connected. So if I go to Tailscale website, I guess is where I'm going to go. And I'll need to log in somewhere. Thanks to those who've been, it's hard for me to see, or I'll try the admin console. All right, I'm already logged in. So here's my server. Here's the fake IP address. Nobody can use it except for me because it's only recognizable when you're logged into my Tailscale software. So we'll and we'll just pop an IP address. There's the login screen for my server at home. And I'll go ahead and log in. Waiting for it to catch up. All right, so I'll go to the dashboard tab on the server. And when I scroll down, you'll be able to see some virtual machines that I have on the server. I have several Docker containers and one virtual machine. Docker containers are a lot more lightweight than the virtual machines. One example I have is Debian Bullseye. I'll go ahead and start it. And then I will go in and hit Web UI, which will take me to a web interface to let me see the actual Debian desktop that I have running. Might take a minute to load.
So you had installed that virtual machine on your machine at home?
Yeah, I had it on there previously.
Yeah.
Oh, you know what? I need to change the IP address. There it is. I had to use the VPN IP address to get to it. So now you can see that this virtual machine is running Firefox. It's a Debian Linux installation using, what is it, XFCE or something other than Node, I can tell that. But it's very lightweight, and the way it operates, you don't really see much of the host operating system. And I'll show you, this is a container. I'll show you how a a virtual machine running on my server looks a little different. How do I get rid of this bar at the top, guys? That would be make it very difficult for me to do it. I'm gonna increase the resolution again here. Sorry, I'm gonna bump it down to 150. Let's see if that okay. Maybe it's behind this thing. Maybe not. Sorry, technical difficulties with the screen sharing setup.
I suppose you could go to full screen, but I'm not sure that we can get
Dual
back.
monitors would help here for sure. Yeah, I just can't get rid of this bar at the top. You guys know how to move that around? Oh, that did it.
You're talking
All right.
about
All right, that's better. I had to clear out the box telling me the meeting was being recorded. So I'll go back to my server, close out the Debian desktop I had running, and I have a Linux Mint virtual machine running on my server. So I'll go ahead and start that. It's going to take longer to start because it's a full-fledged virtual machine, not just a container. It's going to use more of my available server CPU and memory bandwidth. But once it's started, we'll go into it a little very similar. Except on this one, instead of being a container that takes you right into the desktop, this one, it forces you to log in like if you were running Linux Mint on a local machine. And once that goes in here, you can see the welcome screen, maybe run some updates and so forth. But it looks like a regular desktop, acts like a desktop, except it's not a desktop, it's running on the server in my basement. So this is like a VDI, similar to the technology you would use to connect to a fake virtual desktop at your work if you work for a company that didn't want you having a desktop PC at your home. So you can do update manager, refresh, whatever. It acts like a regular desktop here. Let's see how the Arch install is looking. Not good. I had a feeling we'd have this problem. It didn't want to download the files to do the installation. For some reason, when I tried to install Arch on a virtual machine previously, I had the same problem. Something else real quick. Let's create a new one for Linux Mint, which is our Linux distribution of choice for the computer society anyway, right? So I'll go into here. I will add another new virtual machine. Call this one Mint E Freshness. This is brand new. And for the ISO image, we will use Linux Mint 21.3, brand new. We will, oh, whoops, I don't want to use unintended. Why did it do that? Let me try this. Okay, here we go. Base memory, we can give it 32. As long as only one of these is running at a time, you could have 5 virtual machines, each having 32 gigs of RAM allocated. And if they're only running one at a time, you would only ever use 32 at a time. But if you try to run like 3 at a time, then you'd be using more memory than the host actually has. We'll do 8 cores on the CPU again. We'll go 100 gigabytes. Same with the 100 gigabytes. Right now, they both have 100 gigabytes. But the Arch one probably doesn't have much in it at all since the installation failed to download. If we would have pre-allocated full size for the storage, it would have carved out 100 gigs and made it unavailable to other processes on your host machine and also any other virtual machines that you create. I'm not going to do that here. So now let's start up this Linux Mint one. This should go a lot smoother. Although now that I think of it, I think Linux Mint's had trouble installing in virtual machines before too, but we'll find out. All right, we're going to go with the Start Linux Mint. Hit escape here. And it should, this is a live image, so it should boot right into Linux Mint desktop, and then we'll be able to install it there just as if we were booting from a Linux Mint USB drive on the desktop. Just thinking about it.
Well, it likes to think.
There it is. Very small screen, right? Let's up the resolution here. We'll see if it'll let it bump it up just a little bit here. How's that look? A little better. All right, look at this. Alerts. Maybe a little bigger still. Ah, that's good enough. All right, so this looks like a little computer running on top of my laptop Windows operating system, but it's running Linux Mint, and it's just running in a separate process right on the operating system using virtualization technology that's built into the actual AMD processor on my laptop. We'll go ahead and install. And I can't say it's all the time, but a lot of the time installing an operating system in a virtual machine on a powerful host is just as quick, if not more quick, than installing on actual hardware. So we'll stick with English here so we don't confuse ourselves. We'll go for all the bonus media codecs. What the heck, why not?
The true test would be if I install Windows XP on this virtual machine and run my flight simulator.
Oh yeah, you can do that. I mean, the performance wouldn't be as good for the 3D graphics or whatnot. Passing through a GPU to a virtual guest is not always great. All right, gonna pick time zone. We'll use LCCS for the name on this one. Very weak password. All right, now it's installing. See how long it takes. Any other questions while this installs in a virtual machine on my laptop? Virtual. There's a delay. See it. we lost it completely. Everything okay, Everett? Or maybe you just
No,
change. There you go. All right, we're back. Sorry about that. You didn't miss anything. We're still installing Linux Mint in the virtual machine on my laptop here. Now, what was your other question? Were
wait a minute. I'm gonna make
you
sure
see
this,
anything here that might help with your plans to try out a virtual machine eventually?
But you haven't had to go into stuff came down. It's still doing that.
Which one?
Or you had to type install Arch, whatever.
Oh no, that's specific to installing Arch.
It's just for that.
Yeah, installing Linux Mint is a million times easier, and it's actually working. Whereas the Arch one failed. Arch one didn't play nice with the virtual network device that gets created as part of your virtual machine. So while this is installing, let me show you something here. If we go to, whoops, if we go to VirtualBox software and we go to Minty Freshness and we click on settings, there's more settings than what we already had. So advanced tab allows you to share a clipboard between your host and guest devices. System, you can look at your memory, how much memory you have shared. You can share other devices, such as your secure boot from your motherboard, your EFI from your motherboard. We didn't do that for this. If you got a floppy disk, you can share it. Optical drive, you can share it. You can, when your virtual machine's not running, you can adjust the amount of CPU that you allow to have. You can adjust the execution cap percentage CPUs that you shared with it. You can enable hardware virtualization, which we already have enabled. You can change the amount of video memory that you share with your virtual machine. You can increase the number of monitors, so your virtual machine thinks you have two displays, so you could have two displays side by side on this one small display. Then you wouldn't be able to see anything. You can enable a remote display so that you can connect to your virtual machine from another device. You can enable recording of your virtual machine, kind of like we're recording this video. You can add additional storage. You can add shared folders between your host and guest operating systems, so that when you can share your home folder basically from Windows to your guest machine, and your guest machine can access the files on the host operating system.
Are things you allow built up.
Not really, not to a noticeable degree. You can feed through your audio, let your virtual machine play sound to your actual physical machine speakers if you want. There's different options for the technology you want to use for your network connection. You can basically share the network connection. There's a lot of different more details, but you can share the network connection with the host, or you can even make your child operating system have its own MAC address and look like a separate computer on the network. I usually go with the default. A lot of options. You can share serial ports if we have those anymore. You can specify the USB technology version you want to use and any specific devices that are on there. It's like defaults to 2.0 for some reason. I don't know why that is, why they don't default to 3.0. Here's where you can add your shared folders. I mentioned earlier. Here's some customization for your piece. I never really should stick with the defaults on that. Let's see how it's looking.
Once you install that on your computer, it's always there.
Yep. And unless you delete the virtual machine or delete the file holding the the fake computer hard drive, basically.
Log into it.
Yep.
That operating system. Do
like a regular computer, except when you shut it off, you have your host computer and it's not using any of the resources.
Get a virus on that virtual. Can you
Delete it, and it shouldn't impact your host unless you have file sharing set up and it knows how to navigate to the host through shared files. But that's not very common in my experience.
So if, once you get the ISO put on virtual machine, you can't get rid of the ISO.
Once you, it's just like a thumb drive when you're installing operating systems. When you're done installing, you pull out the thumb drive. When you're done installing, you can delete the ISO file and keep going running. But if you want to reinstall again, you have to download the ISO file again. But you'll have a working operating system just like its own computer inside the virtual machine.
It's in there, it's not downloaded.
It can be. I'm going to keep mine in my download, but you can get rid of it. It won't matter. It's not using it anymore. It's using the storage and your. Yeah, that's another good idea. I can show you guys. If I go to my.
go to the CD-ROM and eject it?
Say what?
After the install, you go to the CD-ROM and eject it.
I think with VirtualBox, it automatically disconnects it for the second boot after it restarts the first time. But I wanted to show you guys, if I go to my home directory, I should be able to see my virtual, might have to go to documents. And, oh, you know what? No, I'll have to go to C drive. Users, now there should be a VirtualBox VM store. If you look in here, you see the Arch VM and the Mini Freshness VM. This folder is going to be smaller because we never finished installing Arch. It's only 1.94 gigabytes. This one, the Mini Freshness one, is probably going to be bigger. Yeah, it's up to 10 gigabytes already because that's where it's installing Linux Mint.
So you can delete the one.
Yeah, if I never wanted to use it again, I could. So the installation's done. We're going to hit restart. It's going to prompt us to eject our media. We'll say, all right, I'm going to pull out my imaginary thumb drive and hit enter. Now it's going to reboot.
Do you have to download VirtualBox?
No, that's why if you look at your VirtualBox installation, you can see Arch is still on here, Mint's on here. You could add a dozen of them. And as long as they're not all running at the same time, they're only going to impact the host operating system while they're running. So if I get back to Mint here, you should be able to log in.
So the boot up to that virtual Linux is going to be pretty darn quick, right?
Oh, it's really quick. Yeah, that's another good thing about it. So let's close this out. Make this a little bit. All right. So yeah, you can use this just like you just finished installing Linux Mint on your computer, except it's not a real computer. This is a great way to try new Linux desktops, Linux distributions that you've never tried before. If you were running Windows 10 and you didn't know if you'd like Windows 11 or not, you can install it in the virtual machine. In a virtual machine? In a virtual machine?
Yeah.
I failed to get mine to install on a virtual machine. When I tried it before, I had to use the Tiny 11 that we talked about. But theoretically, it should run fine on a virtual machine, just like anything else. But that's not always the case.
You've got a virtual machine.
Yep.
Could you copy it and put it?
Absolutely. You could, you'd want to do this on a really fast network, but you could have these files holding your virtual machines. You could store those on a server or on a NAS device at your home, and then access the virtual machine files from another computer and run them remotely.
So it's just like a file.
Yep, it's just like a file. If you go to its Mini Freshness folder, the biggest file in here is going to be the actual virtual drive file, virtual disk image. Right now it's 10 gigs. Virtual machine thinks it has 100 gigs. So this virtual machine will take it all the way up to 100 gigs. That's how big it'll get before it runs out of space. But right now, because all we did was install the OS, we haven't put any software files on it. It's only showing up as 10 gigs. it's like Doctor Who's box that he flies around in, right? It's a 10 gigabyte box on the outside, but inside of it, there's space for 100 gigs. Is that a good analogy? You guys do Doctor Who? So yeah, I mean that's really all I wanted to present with you guys. Um, any more questions? Anything else you want to see? It's been an hour.
I have a question.
Yeah.
Can you explain again what a container is and what part that plays?
Yeah, sure. And I think it might be best to share through an example. I'm going to try to bring my server dashboard up here again. This is my server running at home. So my server running at home has these CPU cores, this memory, this GPU, and so forth. This virtual machine run on the server is pretty thick and heavy, just like the virtual machine that I'm running on my desktop. If I want to log into it, it's going to look like it's going to look like a whole computer with the whole operating system. You're going to see like a big BIOS that it boots into and everything. It's just like a virtual computer. These up here are Docker containers. They are a lot smaller. They have much smaller footprint. They're basically, the way I describe them is that they are a virtual machine, but much smaller, and they only contain the portion, like this virtual machine has the entire Linux operating system running in it. One of these Docker containers will share the Linux kernel with the server host that they're running on, and they will only contain the amount of the operating system that they need to run as an application. And the other thing about containers is that, like virtual machines, they're separated from each other. Unless I specifically allow communication between two of these containers, they can't talk to each other. They have to use basically ports like you would use, like network ports, basically. So another way to look at this is if I go to my shares tab here, and I want to look at my domains, which is where the virtual machines are stored. I'm guessing this one's going to be around 10 gigabytes. 100 gigabytes. I must have did the pre-authorization. I did the pre-allocation on the hard drive for that one. And this, by the way, is not a VirtualBox virtual machine. This is the KVM virtual machine because it's running on a Linux server. But if I go back to my shares and I look at my app data, these are all my containers. They're going to be a lot smaller. If I look at the Debian container, for example, it's going to be a lot smaller. 108 megabytes instead of 108 gigabytes. So it's one 1,000th the size of the full-blown virtual machine. So that gives you an idea of how much space you can save using containers.
How did the container get there? Is that an app?
Yeah,
Or
it's actually an app I installed from this app store. This server operating system I use is called Unraid.
Okay.
It has an app store, almost like you see on your phone, except all the apps are made to run on a server. And that's how I run things like my Plex server or streaming movies and so forth. And it shows all your storage devices and everything, and lets you manage your server through a web browser interface. So,
Need those.
oh yeah, these containers, I don't create these containers. I download them from the App Store. Don't even really, except for the iCloud one, I use this to download my pictures from my Apple Cloud to my server. I never really even have to enter a terminal in it. But because this is a container, it's a Linux container, if you want to, this iCloud one doesn't have a web interface. You can't look at it like a desktop. But you can look at the logs for it, see where it connects to iCloud and downloads pictures. And you can also go into a console screen for it and interact with the container just like it is a Linux server. But it's also very lightweight.
Download the
No, you can run Docker containers on any operating system essentially. There's even Docker container environments that you can install on Windows to run Docker containers on Windows. And they're a lot more lightweight than a virtual machine, but they're also usually when you create a Docker container, it's for a single purpose. Like this one, this Docker container, all it does is download pictures from iCloud and save them to my server. This one, for example, all this container does is stream movies. Some of the other ones have their own individual devices. This Debian Bullseye desktop one is kind of a rarity for a container because it's like a full desktop environment that's like pretty thick for a container, but it's still only 100 megabytes. And it's going to be sharing its kernel and everything with the host operating system.
That's like another computer.
Yeah, but it's a lot lighter weight. Yeah. But, and then like some of these containers are going to have web interfaces. Like this one, I'll have to plug in my IP address probably. Because I'm using a VPN to connect to my home server, I'll probably have to plug in the IP. That didn't work. Let me try another one. Doesn't look like it's gonna happen. All right, I can access my Plex account from this link too. So if I was accessing my Plex container, it would look very similar to this, and it would have a lot of settings and so forth. This is the web interface for the Plex application, but then you can also look at the logs. That's what the log currently looks like, and then you can also terminal into it with the console. Anyway, that's the fun world of virtual computing that I enjoy. I hope that answered the question about the container.
Yes, mostly.
All right. I mean, you can find YouTube videos on it. I mean, sometimes it's hard to wrap your head around because it's like a virtual server, just considered to be like a micro virtual computer, basically.
So an ordinary run-of-the-mill person doesn't need
Yes,
containers.
unless you're a nerd like me, you wouldn't need one. But now I will say, like every top 500 company is using containers in their data centers as a way to save money and make the most out of the resources.
I can see how it works fast, but I don't see how it would apply to me.
Yeah, it probably wouldn't.
Thank you.
I only have them because it's fun for me, basically.
I like to use virtual machines. Do all my banking in one virtual machine. All my medical records and stuff in another virtual machine. Like you, it's more for a team, but it
Yeah.
does give a little more security.
A little bit, yep. I mean, another option could be going over VPN,
Yep.
that kind of stuff. Yeah, I just use my host operating system for all my web browsing and stuff. But now, another use you could use for a virtual machine is that, like, I don't know if everybody online can hear Ken, but he says that he uses a virtual machine for some of his like, he'll use a virtual machine for his banking and a separate virtual machine for, what was it, medical stuff and so forth. Another way you can use a virtual machine is that, let's say you're running Linux Mint in this virtual machine, you could install a VPN on this virtual machine, and it would basically mask your location and all the data you're trying to receive from that virtual machine. It wouldn't be visible to your internet service provider or anyone else watching your internet traffic unless they got into your VPN provider. But that can come in handy if you were, let's say you have Netflix and the movie you want to watch is no longer available in America, but it's available in Britain. You can log into your Netflix, trick your virtual machine into thinking that you're in Britain and watch whatever show you want. Just one example. That's how you can use a VPN to basically fake your location, but you can do it for like freedom reasons and so forth. If you live in a country where you don't have free speech, you can use a VPN inside of a virtual machine to pretend you're in the United States and basically access anything that we're allowed to access here as far as free speech goes. All right, I think that's probably, I think we're past our point of presentation. Thanks everyone for being here. Feel free to reach out to me if you have any questions. Everett is gonna stop the recording, I hope, so I can stop blabbering. There we go, and stop.
Okay, here we go.